All right, the final operation we're going to talk about with functions is the composition of functions. Composition of functions is denoted by an open circle, like this, and it basically means f of g of x. This would be red, f of g of x. All right, what you're finding when you do composition is a rule for doing one function immediately followed by another function. So for example, if f of x is 2x plus 7 and g of x is a negative 5x minus 1, and I asked you to find f of g of x, which means the same as this, we are using g of x as the input into the f function. So we're going to put g of x into the input for the f function. We would be left with 2 times negative 5x minus 1 plus the 7. If I distribute the 2, I have negative 10x minus 2 plus 7. And if I combine like terms, I have negative 10x plus 5. Now, to kind of demonstrate what this means, if I would ask you to do f of g of 3, one way of doing this, doing your parentheses first, is to do g of 3. Putting g in for x gives you a negative 16. Then putting negative 16 in for f, we have a negative 32 plus the 7, which would be a negative 25. All right, so we're doing that in 2 steps. What we just did here is we developed a rule for doing f of g of x. So to do f of g of 3, I should be able to just directly plug 3 in for that rule. I would have negative 30 plus 5, which is a negative 25. So we're developing a rule for doing the g function followed by the f function. Now, order is important when you do this. So if I asked you to do g of f of x, now we'd be putting f of x into the g function, f of x into g, and I would have negative 5 times 2x plus 7 minus the 1. Distribute. Combine like terms, it'd be negative 10x minus 36. So showing what this means again, if you do g of f of 2 and you do f of 2 first, putting 2 in for f, you would get 11. And putting 11 in for g, you'd have a negative 55 minus 1, or a negative 56. Now, if you just put 2 directly into this rule that we just found, you would also get negative 56. Here's another example. This is using some quadratic functions. So if I'm going to do f of g of x, again, that means I'm putting g of x into the f function. So I would have negative 4x squared. I would square all of that minus the 1. So now using our properties of exponents, I'm going to square negative 4, which is a positive 16. I've got power of power here, that'd be x to the 4th. And so that function would equal 16x to the 4th minus 1. If I did this the other direction, if I did g of f of x, now I'd be putting f of x into the g, f of x into g. It'd be negative 4 times x squared minus 1 squared. So how do you square x squared minus 1? You could write it out twice. FOIL. So I'd have x to the 4th. I'd have a minus x squared a minus x squared, a plus 1, which is x to the fourth, minus 2x squared plus 1, and I would multiply by negative 4. So I have negative 4x to the fourth plus 8x squared minus 4. That would be the rule for doing f of x followed by g of x. So I hope this helps you with composition of functions. Another type of function we could do using this is if I've got a couple different functions. Let's say I have that f of x is 3x, g of x is x plus 4, and h of x is x squared minus 1. So I have three functions, and if I would be asked to do, let's say, g of h of negative 3. So now you would do h of negative 3 first. You'd put negative 3 in for x right here. That would be 9 minus 1, or 8. So now I have g of 8. I put that into the g function, and I would get 12. Now you could do a rule for g of h of x, but if you're only doing one particular problem, it'd be easier just to plug in and do it with the multiple times. It could involve even more. Let's say you've got f of, g of, h of, negative 1. Okay, so we're going to do h of, it basically means the same as this. I'm going to do innermost parentheses first. I'm going to do h of negative 1. If I put negative 1 in for x, negative 1 squared is a positive 1, minus 1 is 0. So now I have f of g of 0. I would then do g of 0, which would give me 4. And then I would do f of 4, which would give me 12. So that's another example using composition of functions.